microphone. So my name is Tom Lambert, and I am the Arlo lead engineer. So once upon a time on the internet, a bunch of people grouped together and in order to work on a complex engineering problem called the Hyperloop. In this presentation, I will be talking about their story and the power of the crowdsourced engineering. So in this presentation, I will first talk about the Hyperloop, what is this crazy thing, and then I will talk about Arlo, the team born on Reddit. After that, I will go a bit into the details of crowdsourced engineering and give some example of that through the Arlo project. There are currently 4 modes of transportation. You have the plane, you have the boat, you have the train, and you have a car. In 2013, Elon Musk and SpaceX proposed a 5th way to transport people called the Hyperloop. The idea behind that was to have the convenience of the train and the speed of the plane while still being affordable enough that mass people can take it. So this is what they suggested it will look like. Basically, you have a tube in which you make a vacuum. Inside that tube, you will be shooting a pod at very high speed. And that pod is levitating. So you have no friction, almost no friction from the air, and no friction from the ground. The idea behind that is that it's a very efficient system. All the energy used for propulsion can be used for actual propulsion, not heating the It's also advertised as something that is very green, very fast, convenient, all the things you want. Something that really sounds 21st century. As I mentioned, it's something that goes very fast. We're talking about something that will go from LA to San Francisco in 30 minutes. Obviously, it's something proposed. It's still like the end game. We're not there yet, far from there. That's the kind of stuff we'll be touching about in this presentation. So the Hyperloop is divided in 2 main systems. The first one is a pod. So in the pod, you have a cabin, like the cabin you find in an airplane. In front of the cabin, you have a compressor. The reason to have a compressor there is that when you have something going fast inside the tube, even if it's in vacuum, on low vacuum, you still have molecules of air that will come up in the front, and that will slowly form a cushion to slow down the pod. To get around from that, what you need to do is to move that air somewhere else. That's the goal of the compressor. A compressor will be sucking the air, which will be used for life system on board or for levitation, air bearing levitation. Speaking of levitation, you have air bearings, which is the same system as you have on the hockey table. So you're just blasting air underneath you in order to levitate. Or you can use a magnetic levitation. The whole system will be fully electrical, so a bunch of batteries, no fuel, no fossil fuels. On the track, you will have linear induction motors. So it's the same stuff as a railgun, basically. It's just an open electrical motor. So when you have something going over it, it will accelerate the pod. You can see that as kind of if you ever played Mario Kart, so it's accelerating platform. It's kind of the same idea here. You go over to this platform, it will accelerate the pod, and the pod will be cruising down the tube until it reaches the next station. Second part of the system, you get the tube. So the tube would be most likely made of steel tube, of steel material. Usually you see those things made of like transparent material. It's really for PR. I don't think they will actually make those transparent, they will be opaque, because I don't see acrylic or stuff like that be done, but I just think. On top of the tube, you have solar panels. The idea here is the solar panels provide most of the energy to the Hyperloop. The power will be used to run the linear induction motor I just talked about, and the vacuum pump that are required to suck out the air from those tubes. The whole structure will be raised onto pylons just to keep it off the ground. So, as you kind of guessed from giving you this cool futuristic thing, there are a lot of challenges. And just to mention a couple of them, you have it's going to cost a lot of money. In the Hyperloop alpha paper, the alpha paper is a document that was put together by SpaceX, kind of going over the grand line of what the Hyperloop would be. In that alpha paper, they were talking about $6 billion for a road from LA to San Francisco. They were a bit optimistic. It's more like $20 to $100 billion. So money will be a big problem, obviously. You're gonna have to maintain the low vacuum. We're talking about huge tubes, long section of tubes, and you need to make very hard vacuum in it. That requires a lot of power and very, very strong pump. You have thermal expansion, seismic activities, we live in California, the safety, making sure that all that complex system works together. So there is a lot of problems. You can find a lot of excuses for that thing to not work. But all in all, there is no real showstopper, and I've put 4 optimists. Of course, you can say, all right, that's too expensive, there will be a problem. Yeah, you can find something to kill it, but it's a fun engineering problem. Let's just work on the thing. We don't need a breakthrough in physics to make that thing happen. We just need to be smart and try to find a way to make that thing work together. So it's challenging. In order to kickstart a bit the research, the R&D for Hyperloop, SpaceX decided in 2015 to create the Hyperloop pod competition. So that competition was aimed toward students' team mostly, but everybody can join. And the idea was, you guys come up with design, and we will find, we will select the best design, and the best designs will be able to build a pod, and that will be raised down in a track test facility at SpaceX headquarters. So SpaceX proposed the idea of the Hyperloop, but you have to know they're not building it themselves. All they said is, please have companies work on it. And one of the biggest problems for the companies, especially startups, R&D. Everybody know, R&D is not something you make money out of. It's not something that's interesting for venture capitalists also. So I think it's a great approach for the problem to just make a competition. There are 2 ways to make big innovations. There are wars and just friendly competition. War is still a competition, but just, So this is, I think, a good idea. At the time the announcement was released, there was a message on the Reddit board. So Reddit, for the one that's not familiar with it, it's a social board online where people will post news, questions, pictures of cats, the usual internet stuff. And that message appeared in the SpaceX subreddit. So it's a Reddit plus where a fan of SpaceX basically. In a nutshell, it says, let's work on a Reddit entry for the Hyperloop competition. And that post got a lot of interest. A lot of people joined in and say, hey, I'm a mechanical engineer, how can I help? Or I'm a web developer, I can make you guys a website. Or I have no technical skills, but hey, I'm willing to put some money for you guys. So we started to see the whole thing buzzing over the internet. And we started to self-organize. We say, we should have, okay, what should the team look like? We should have a project manager, we should have a lead engineer, we should have an aero team, this and that. And people from Reddit started to apply to those jobs. They said, hey, my name is Tom, I'm a mechanical engineer, I want to be the engineering lead, this is my background, I want to run for the lead engineer for mechanical. And people on the internet would be voting and say, yeah, I'm for this guy, so it will be a popular vote for who will be get those positions. And slowly, all the people collected, and we had a list of all the people that wanted to create that group, and here was born rLoop. So rLoop was the initial name, which was changed to rLoop later because we are not affiliated with Reddit, they are not backing us in any way, just happened we were born on Reddit, and to be honest, rLoop just sounds more sexy to prefer the name. So in the beginning, it was a real mess. I remember the first meeting we had with Slack. We had like 50 people chatting, everybody pushing their idea of what they think we should do, and every guy, it was nightmarish. I think like 20% of people quit after that, most probably. Okay? So there was a lot of stuff to do, but slowly we got organized and we got structured. People started to, okay, let's focus on this. And it's really amazing to see what the community can do to organize themselves without any authority, increasing themselves the authority. So 8 months later, this is where we were. We are now a 501c3 in California. We are fully open source. Everybody can join at any time. We have more than 300 members over the internet, and we have a core team of 40 members. The core team are the people that have been around for a long time, the people we know we can count on. We are representing more than 15 countries in the world. You can see the map. in the bottom right there, it's people are dropping a pin where they come from, and we're basically on every continent. So we have just one guy in Africa, but in every continent. And it's just amazing, you know, just so many people, a lot of different skills, and I have a lot of other stats I can blast to you, but it's just great to see all those people. You can see some of the faces of different parts of the world here, with my picture of Hangar 1 on top right. That was for a crowdfunding video, I think. So a lot of people coming together towards the goal. So back to the competition now. It was a very tight schedule. There was basically something to do for every 2 months. In August 2015, sorry, in September, you had to submit an intent to compete. It was just to say, I have a team, I want to compete. There was 1,800 teams that applied for it from all over the internet, all over the world, sorry, through the internet. The first big deadline was in November, where you had a preliminary design review. The idea was to just send to SpaceX 40 slides highlighting the high-level detail. Okay, I will have a pod using that type of levitation, that type of brake, the dimension will be roughly that, so just, you know, rough idea. 320 teams were done selected after that. Half of them were students. After that, the next big and the latest biggest report milestone we had was the final design package. That was, so each time it's like a huge step between each of those milestones. The last one was really very detailed design, very detailed report on the design. You had to go in every detail. SpaceX had over 50 questions they wanted to see answers to. What happens if the tube breach? How does the shock affect your pod? What, you know, list all the chemicals you will be using. You know, what are the way you expect the pod to behave in that case. We had more than 200 pages for that report, full of simulation, different things. I spent half a week not sleeping just to put the bits together at the end with everybody. It was all over the internet. We had a Google Doc, and we had like 40 people. You can see like 40 people working at the same time. Google Doc. It's wonderful to see, but oh boy, it's really tough. After that, 120 teams were down selected for the design weekend in Texas. The design weekend was basically, it was in College Station, the beautiful campus of College Station. It was in a stadium, and there were booths everywhere, and everybody had a booth. Each team was sitting there and pitching a bit about their idea, how they think the pod should be. And you had 80 judges for 120 teams that were roaming around, experts from the industry, experts from everything that were there, and they were scoring all the teams. So this was actually the first time, so 6 months later after the creation of Arlo, and after finishing all the milestones, this was the first time any members of Arlo ever met. We spent all our time working over the internet, on Slack, we did a lot of stuff. It was really fun because it seemed like someone that you really know, you know the personality, but yet you never met him. So it was really real time anyone ever met. Those are the two first persons that met at the airport, the two Arloers that met. It's Eric right here from San Francisco. He's a crazy guy streaming right now. He met with Amir, who is our numerical simulation lead. This guy comes from India. He took a plane for 28 hours total trip to come to the weekend. Talk about dedication, right? So we had a total of 9 members, and this is our happy group with all the members that were there. And again, that's, you know, it was crazy to see what you can do over the internet that has an impact in real life. You know, we had one guy saying, hey, for the weekend I can do some cool mug rLoop, and another guy said, I'll make some flyers, and the one said, I'll make some bandroll, some cool design. And then, you know, I arrived from there, and we put the whole video, it's like, wow, it looks actually really good. Because, you know, when you do stuff online, you don't expect it to really work, you really doubt a lot of yourself. So that was really great. We learned very quickly by one of the organizers that because we are a non-student team, one of the 50 non-student team, we are not eligible to continue after. That was a real real letdown for us. We never talked about it before. And so, you know, but we kept the mood up. We said, okay, we did all that stuff so far, let's continue, let's move on. who cares? We just continue on. We do our own competition, you know. And then something happened. I'm not sure if the song's gonna work. So they just announced Arlo, the non-student team that will be going forward. And if you look there, it's like they just announced nothing's happening. And like, okay, what's happening? Is there? Where's the guy? What's happening? Is there someone coming up? The reason behind that is because we're told that we cannot win the award, we cannot go forward. And so everybody was just scattered around. Nobody was watching the award. Everybody left, basically. And it's a good thing we had Brent sitting next there saying, oh shit, oh, we won something. Went on the scene to pick up the award. Great moment. I was actually on a plane back to Belgium at that point, and when I landed in New York, I had Brent over the phone. It was like, we won. What do you mean we won? We won an award. I said, wait, there is no award for us. So yeah, they made an award for non-student team. So no, stop. Okay, there we go. So 23 awards, 22 for non-student, 22 for students, 1 for non-student, and we managed to get it. So we were happy, the happiest guys on earth. After that, we had a big Airbnb house. We invited all the teams to the big party. The police stopped by and shut down the party. So it was great. And Eric still has the PV, the note from the police saying, stop your stuff. So that was the proudest moment we achieved. So we got a nice award with some. It's a cool award. It has some alloy from the Hyperloop steel that will be used, and Elon Musk put an autograph on it. So we have a little piece of Elon there. So people are crazy. And that was crazy. So what did that award buy us? It bought us the right to continue for the final step, which is to go from theory to practice, to actually build this thing. So the way it works is SpaceX is designing the tube. This is all drawing from the tube because when SpaceX asked us to not put the drawing of the tubes or to not publicize the drawing of the tube, that's an old one you can find online. It's not up to date anymore, so I guess we're fine. It gives you an idea what it will look like. So you have a steel tube. In the bottom, you have a concrete slab. On the concrete slab, you have 2 subtracts of aluminum, so 2 plates of aluminum. Those will be used for either air bearings levitation or for magnetic levitation. In the middle, you have an I-beam, which can be used for braking, it can be used for alignment, for whatever you want. So the track will be 1 mile long. It will be in SpaceX headquarters. It will be, the pod doesn't need any propulsion. It will be pushed by a SpaceX pusher, which is, you can assume some type of turbocharged Tesla pushing the thing. And they talked about powertrain of Tesla, something like that. But I know there is no turbo on electrical vehicles. Don't throw rocks at me. So pushing the thing. So the idea is really to have a technological demonstrator. It's not to show what the final pod will look like. It's really to show that you can put all the pieces together and that it works. So this is what Arlo came up with. It's called the R-Pod. This is a nice rendering of the pod levitating. It will look something like that in the end. That's one of the latest versions. So I won't go into details of everything we have on board because otherwise the presentation would take forever. So I will just concentrate over the 2 next slides into the the important things. So the pod is divided in 2 structures. You have the pressure vessel, you can see with the 2 half hoops there, and the propulsion substructure, which is the part in the bottom. The pressure vessel is designed the same way, using the same design method that I use for business jet engine. We have some people working for aircraft in design structure. It's good for us. We're using the same approach. We're using a lot of stuff that already exists. We're not trying to reinvent the wheels. We're just trying to put a lot of different things existing, commercial off the shelf, together. You can see inside a person. That is because SpaceX is giving us a crash dummy to put inside. So that's our little dummy in there. It'll be sitting on 2 batteries. They don't care. They said put the dummy in there as long as it's not like folded in the glove box. So this is what we do. I wouldn't write there. So we have a fairing. This question I often had is why do you have an aerodynamic fairing? Well, everybody talks about vacuum. It's actually just low pressure, very low pressure. It's not exact vacuum, it's not space vacuum. So you still have some aero effect coming into play. So you have to have something that is shaped for that. For the bottom structure, levitation, sorry. For the levitation, we are using 8 Hallback arrays. So Hallback arrays, those are basically a bunch of magnets that are put onto an engine. And then if you make that engine turn very fast, and you make that thing go over a conductive plate, you will create some eddy currents, say that plate, which create a force, and you'll have that thing levitating. That's the idea, just rotating magnets. We'll be using 8 engines, 8 hover engines from Arxmax. They are in the area here. I forgot the exact place, but they are Silicon Valley people. They are, we're using the same kind of engine that are in the Hando overboard. I climbed on one of those things, really fun. And so that's what will be providing our levitation. So the levitation substructure, we had 8 of the engines. You can see the wrong things over there. 4 of them are gimbaled. The reason for the gimbaling is that if you tilt those things inward or outward, it will actually create some thrust or some braking force in the direction to the car. So that you can use that for some attitude control, for some braking. For the braking, the main braking system will be eddy brakes. It's the same system of brake that you have in roller coaster. It's very simple. It's a bunch of magnets, also magnets, that you bring toward the I-beam. And when you go at very high speed, if you bring magnets next to something conductive, it will create a drag force, very high drag force. The alignment system is just a bunch of wheels that will be attached to the I-beam. On the 4 corners, we have backup wheels. The wheels are sitting lower than the hover engine, and the idea here is if something happened, if the power shut down, or if we have to shut down the levitation for some reason, the whole structure can fall onto the wheels without destroying the subtrack or just destroying itself. So again, two slides to show all the stuff. That took a long time to get to that. It might seem a bit simple, but there was a lot of CFD, FMEA, Maxwell simulation, just overall math, checking iteration and stuff. A lot of problems we run into. This is one of the latest versions we have so far. We still need to nail design. So that's really interesting to see what people can reach just over the internet, make such complex system. Which brings me to the second part of this presentation about crowdsourcing. So what is crowdsourcing? Crowdsourcing, outsourcing to the crowd. You're asking the crowd to help you on a task, you ask a question, you want to have everybody look toward the same direction and help with something. If it's something unpaid and over the internet, you can also call it online volunteering. It's the same thing as volunteering. You're volunteering for a kitchen soup, but it's using the internet. You have much more visibility and much more people that can participate. This is a very powerful tool. This is used for a lot of stuff. This is a lot of people working toward the same goal. It can do a lot of great things. If I had to ask the internet if I had to crowdsource this slide to the internet with just this thing, online crowdsourcing can lead to great things. I could have this slide, which highlights some of the best crowdsourcing exercises you had so far. Quora, which is a crowdsourcing by question. You ask a question, the community gets back to you, and the community will vote what is the best answer. Wikipedia, everybody knows it, but it's crowdsourced, people directly push from people. You have also other type of crowdsourcing where you don't need direct action except installing a software. For example, all the at-home exercise, which is basically you install a software, and every time you don't use your computer, you will have the software using a new CPU to run some calculation. In this case, with settings to look for extraterrestrial signal. You have also the reCAPTCHA that you use every time you fill in a form to prove that you are not a robot. That those texts are actually used also to do some verification, some algorithm on how when you scan books, basically to do automatic detection of words. There was a question in the back? Yes?
Yeah, you left out things like, innocent, the super smart genius thing that Eli Lilly built.
I left out a lot of stuff.
Yeah.
There is a lot of stuff, obviously, and everybody can even try to pitch in their own crowdsourcing activity. We're just mentioning here the most important thing, the most visible, the most known one, but of course there are a lot of them. So going back to my rhetoric, which was, if I ask the internet to crowdsource this slide, I could end up with this. If I ask to another crowd on the internet, I could end up with this. So basically it shows, really, it depends what people want to do. You can have destructive crowdsourcing. For example, on the top left, there was a competition to vote for a school where Taylor Swift would be giving a free concert. The top rated school was a school for deaf kids. Kim Jong-un was elected Best Person of the Year 2012, according to a Time internet poll. And Mountain Dew asked the internet, help us find our next drink name. So they asked the internet, put in names and vote for them. The top voting name was Hitler did nothing wrong. So, and there are a lot of other examples. There are a lot of stuff on the internet, so it's all about what people want to do with crowdsourcing. It's all about the objective. It's all about what the very powerful weapon you want to turn in at. It really depends what the people want to do. Online volunteering, people that are usually not paid, they have a day job, they do something on the side, and they want to do something they believe in, or just they have fun, or they are interested in. And as I said, very powerful having so many people working together. An analogy I really like is this one. Maybe you cannot see it very well. This is the cube, the Borg cube, the Borg spaceship. For the people that don't know about it, the Borg are, in Star Trek, a community of cybernetics people, and they have no individuality. They are all interconnected, there is no leader per se, and it's all the hive minds, all the mind working together that creates the big thing. Crowdsourcing are the Borg. It's basically a lot of people that if you took them alone, they are meaningless. Not meaningless, but it's a very small increment, very small stuff. But when you put all of them together, you get something extremely powerful. You get something very great. I'm not saying the Borg are great. They were working toward one goal, which was assimilating everything in the world, which created some problems. But crowdsourcing are kind of the goal. It's a hive mind. So a lot of people working together toward one thing, and if you took just the idea alone or just one person alone, you cannot achieve the same result. So if you turn that hive mind towards something like solving complex problems, like crowdsourced engineering, you can get interesting stuff. And I mentioned here to self-complex design. The reason I say that is because there is already a bunch of crowdsourced engineering. For example, you have companies that want a new logo for a t-shirt. They will ask out the internet, make us a logo, and then they would pick one. That is crowdsourced engineering, people working and developing something. Here we're talking about crowdsourced engineering where you have a lot of different parts that need to fit together. A lot of parts that, different people that don't always speak the same language. You can have a software guy and an aero guy that don't speak at all the same language. So you need some more project management than some other open source project you have out there. It needs more, it's a more complex infrastructure. It involves a lot of micro work. Micro work, which is the key in crowdsourced engineering, is the art of having a complex task and breaking it down into a lot of bite-sized tasks. And the idea is, those bite-sized tasks, this is where the crowdsourcing can come in. You lay down all the tasks people can do, and they will jump on it on the one they're interested in. It's obviously not easy, it requires a lot of time, more time investing, it's a lot of stuff, but you have access to a lot of brain power. And it's really interesting to see when you have a complex engineering problems, and you have 1,000 people looking at it, and you can identify a pattern, okay, people really seem to go in that direction. Or you can have just one guy saying, hey, you guys didn't think about that. If you had 2 engineers, you don't have that kind of stuff. So it's a very interesting thing. Let me give you some examples with how we work with, at rLoop. So it's a very flat structure. We have the project manager, which is Brent, and the lead engineer, which is myself. We interact a lot. We kind of separated the technical and the non-technical side, but we still do a lot of stuff together. Underneath us, there are the leads for the team. The leaders are not always the most experienced one. They are usually the most active, the people that are most available and ready to help, and that have the best communication. After that, you have all the members, and all the blue, you see different blue teams there. It could actually be a big blue pool, because those people are not bound to a team. The way we work is, you have people with tag in their Slack username, so you have like mechanical tag. So the idea here is not the team of the person, but more what the person is interested in. So in case we have a problem with mechanical, we can contact those people first. But we can have someone from mechanical say, hey, that task in software looks cool, that bit-sized task looks cool, let me tackle it, and that's the way we've been working. Another big important thing is having an HR team in a way that people are always ready to welcome newcomers. We saw it's been a problem with us, just hitting a lot of newcomers. It's hard to manage the influx, and because it's a complex system, people can arrive and just see the finished product and say, oh wow, it's very complex, I don't think I can help. And so there is a lot of bounce back, so we need people to see how they can help and find their way through. Project management over the internet is not an easy thing. You have the incentive on people. You can tell that guy, if you don't work more, I will fire you, or the vacation or whatever. They don't care. They do it for free. They can leave any time. But it's really about having the whole mind working together and going to the objective. In terms of tools we're using, we are mostly using Slack to go to everything happens in Slack basically. This is the place where we discuss. We have team leads. We have channels for every team or topics. That's where we discuss. That's where when I connect up in the morning, if I want to check, I check my emails and I check Slack. Funny enough, we are not using emails at all. We are never using emails. Everything happens in Slack. I think emails are great for external communication. I think they do an awful job for internal communication. That's my point of view. So Slack is what we do. We use Google Hangout for our meetings. We use Skype when we do interview, when we talk with sponsors. Google Drive is where we have all our stuff. GitHub for the code. Trello is where we keep all our tasks, or bit-sized tasks. We put them all on Trello, and people can just say, hey, I want to take that task and put their name in. We are using Fusion 360, Autodesk Fusion 360 for all the CAD modeling. It's basically, it allows you to do CAD over the air, so over the cloud. You can have a lot of people from different places working on the same piece not the same piece, but working on the same, very powerful tool. You don't have to send SolidWorks files around and stuff. So, in this slide, I will spend some time on its very ambitious name, how to make crowdsourcing engineering work. This is based on my modest experience. I am not an expert. I've been doing this for 8 months. Those are just some experience, some stuff we saw that worked, some stuff we had to implement to overcome problems. Most important one is, so that slide was actually crowdsourced also through rLoop, so sometimes stuff moved. I had a Star Trek communicator for communication, and we moved it. I guess I put too much Star Trek stuff in there. So communication is one of the most important things. It's really the most important thing. Some people will tell me, well, a lot of those things apply for normal project management. I agree. But those are really more crucial than usual. So communication, communication, communication. If you don't have people talking, you have people not knowing what's happening, you have people doing stuff in parallel, so it's redundancy of work, you have people going in different directions, which brings us to documentation. When someone does something, they need to document it. I tell very often in the Slack channel, guys, if you do some math, if you figure out something, don't just dump it in Slack. Slack is just, it's just the scene. You have stuff going all the time. It's good if you catch it, but if you don't catch it, or if you want to come back to it later, it's gone. It's wherever it gone somewhere. So if you put everything in one document at one place you can refer to, it's very easy. It makes it even easier for the newcomers. Newcomers need to access that information and don't say, hey, just scroll down Slack and see a bit what we do. No, they need to be taken care of. I mentioned earlier that people doing this for free, for fun, they want to have fun. So it needs to be, you need to make really clear what the objectives are. You need to make sure the motivation is there, that they approve the decision you take. Decision can be taken sometime with the whole crowd. You can have everybody say, okay, this is the problem we're having, how would you solve it? And we did that, for example, for the air bearings versus magnetic levitation. There was a lot of discussion, and we said, okay, let's do a vote, let's do some pros and cons, and let's do a vote. That's how it worked. But some other time, you need to take the executive decision. You cannot let always the crowd select for everybody because it just doesn't always work. You need some authority at some point. But those decisions need to be taken in a very, very educated way. Make sure to listen to everybody, even if you don't agree with them. Which brings me to, you need to be able to accept criticism. This is very important. Over the internet, people are more prone to tell you, what you're doing is shit. They will tell you, I hate what you do, I hope you die tomorrow. Check the YouTube comments for any video. It happens, so it happens all the time. No, nobody told me that yet in Arlo, so I think that's good. But you need to be, sometimes people will be telling you directly stuff problems, which is a good thing. Because I prefer having people telling me what is wrong than having people just nodding and say, yeah, yeah, and agreeing. Because those are the people that will be leaving. So you need to be able to take criticism, take a step back, and be flexible with the objective. But at the same time, you need to be able to keep a tight ship, make sure everything goes forward, and you keep people focused onto one direction. People on the internet get very easily sidetracked. We never had a YouTube or Wikipedia moment. You want to check, I don't know, the average weight of the person in 2012, and you end up 10 minutes later on nuclear fusion for no reason. It's just the way we are. We are curious, we go every direction. So you need to have some people at the top always checking we go in the good direction, while not being too restrictive either. Again, people do that for fun. If they want to sidetrack a bit, they need to, but you need to be aware of your deadline. Another thing also I have is always have a backup. And I have one slide to explain it. Shooting star. It's what I call shooting stars. You have a guy joining in, he does an incredible job. He's the most awesome guy. He knocks down like 2 years of job in 1 week, and then after a couple of weeks he's gone because he doesn't have time, because this or that happens. So it happens all the time. That's something I had a hard time dealing with in the beginning. People joining, doing a good job, and then leaving, you'd be like, oh no, I have no time to do that. So it happens. So you need to always have a backup, always be ready, and if someone has to leave, what will I do? It's also a bit cold, but you have to be ready for that. If that guy leaves, what can I do about it? That was something very valuable lesson I learned. That's why I had on slide. So where do we see the future of crowdsourced engineering? Crowdsourced engineering is used nowadays mostly for stuff only on computer. Let's say like code or design, stuff you can do easily on a chair. And it's also usually for one-time job, except for open source projects, it's more complex. However, we think that it really has its role in the future for the R&D in the more typical, how you say, the old industry, not the Silicon Valley type, but more the old industry for R&D. R&D is a huge money, not loss, but investment. And I think using some of the tools that exist today can really help the current state of R&D. Imagine, again, 1,000 brains working towards one thing. What would you do if you had 1,000 brains to solve something? What would you use it for? For good, for bad, for just solving your homework, whatever. But it's a very powerful tool again. So where do I see personally where I would like to see crowdsourced engineering? Those are some of the stuff I like. Asteroid mining, planet mining, full electrical airplanes, or interstellar travel. Why not? Again, those might be more far out, lots of stuff to solve, but if you use the whole crowd, everybody, to work toward the same goal, I think that kind of solution, that kind of approach can definitely yield to something. So, going a bit back to Arlo, what is our next step? Our next step would be to go from the internet to real life. This is going to be a huge step for us. It's going to be a complex one of the most complex, I think. We'll have to bring all the parts together and build the part. The way we are planning to do it is using micro-manufacturing. So you had micro-work earlier, so micro-manufacturing. The idea here is to have multiple places in the US where you will be doing some machining and assembly of subsystems and then send them all to a central location for bigger system. And once you have the whole thing, you can go back and forth. We'll be trying that and see how it goes. By the way, if you guys are interested, or if you guys know of anyone that want to work on some hardware, or if you know someone that has a hangar or machine shop in the Silicon Valley, we're looking for some more places in the Silicon Valley to do that kind of stuff. So, and I think it's a good crowd for that kind of stuff you're doing. So, if you know something about that, shoot me an email, come talk to me, and we can talk.
Look your email.
I'll give you that at the end. So in order to build that part, we are doing crowdfunding campaign. We're on Indiegogo. We started 2 weeks ago. We have over 40% funded so far, so it's going pretty good. We have a bunch of cool perks like mugs, and shirts, and jackets, and levitating pod. A lot of cool stuff actually. And we have some more stuff coming up. Will be announced shortly this week. We have some major backers that showed up. So how can you help? 3 ways. You can contribute to the crowdfunding campaign. You can join us in Arlo. It's open source. You can join and stick around if you feel like it. Leave if you don't, or just give us advice or whatever. Arlo.org. Just join. If you are in California and interested in manufacturing and building stuff, we need more people from the manufacturing team, as I just described. You can send an email to contact@arlo.org or just come talk to me. I have some Arlo business cards just made for today, so I can give them away. Please take them, I have too many of those. And on that is the end of my presentation. Thank you very much for coming, and hopefully, you either learn something or inspire you to do something with crowdsourcing generating. Thank you.
Few questions. Can we take some questions?
Yes.
Okay.
Any questions? Yeah.
So one of the old axioms is the best way to make a late project later is to add more people to it. And you're adding people all the time. How do you get around that?
Can you repeat the beginning of the question?
So one of the old axioms is if you want to make a late project later, add more people to it. And you're just adding so many people here, you have to bring them up to speed, you have to tell them where you are, you have to get them oriented. That's a huge effort, and companies struggle with this, and you seem to be doing it seamlessly.
And that's why we have a team. That's why in the slide, the old organization, we had just a pointer for the HR team, because they deserve that arrow toward them. It's very important to have people taking care of newcomers correctly, inspiring them, showing them what they can do. We have welcome document, something that I pushed the last week to put. Just a document, one-stop document, explain, okay, what you should do when you join. Here is the documentation, here is the stuff you need to do. And the idea is once they've done everything in that welcome document, they are up to speed enough to help on the project. And because all the tasks are broken down into simple tasks, you can really take them without really knowing much except what is around it. You don't have to know about the whole system.
Whole system up in a little part so you can have people get started with that.
Yeah.
And you have documentation. This would be a community generated thing like a wiki or a...
Yeah, we have the final design report, which basically contains everything. It's kind of a wiki. It's pretty well organized. People can go on it and use it to find their bits. And also we have a Slack channel where people can ask questions. That's a great thing with the internet and crowdsourcing. We have people in China, in India, so there is always someone online. So you can ask questions, there'll be someone answering you. It's definitely a challenge, but I think the approach of having tasks that if you come in and you see that task, you should be able to just take it without knowing anything about it. It's like design a bracket to hold that amount of pressure, for example.
Got it, so you make devices.
Okay. I have no idea. Yes, sir.
Is it like a repository index where you have the different categories and stuff like that?
Yeah. For the tasks?
Yeah.
Yeah. So what we're using for the task What we're using for the task is the Trello board. So it's an online thing where we're putting all the small tasks on, and that's where people are. They go when people join us. We tell them get a Slack account, get a Trello account. Those are the two things they need to do some work. So that's where we have all the tasks. Yeah.
Really, in smart sourcing incentive by Eli Lilly, and even the U.S. government has a DARPA site where they pay people to solve problems. Like when they have the oil slick, the guys at Innocentive did a special one for that, and we work with the crisis camps. So you literally, just like we do open source projects, and for hardware too, like if you've ever done contracting or that's one of an emergency project, like literally I work with the guys at Google and like the Red Cross. We built a tool to dig out and tell the Central Command where did they actually dig people out in Haiti just losing GRSS. All you have to do is good documentation, standard tools. I would add messaging. Trello's good if you can do the calendar part, but what sucks is Google's cut off like SMS. And literally with calendar updates, where as soon as somebody does something, everybody gets a text message. They don't have to look for an email or chat. Like people use Facebook messaging and other messaging. It works really well if you iterate it well. Because you've got some type of alerting and some version control systems. Doesn't matter what you use. What's your biggest problem though that's keeping you up at night that you don't know how to solve? And what's the next step that you're not clear about? What do you know you're wrong about? We know we're wrong about 30% of it. 30%. We know we don't know, we're still wrong about that.
I know the big flaw with our system is building the pod.
Building what?
Building the pod. Building the pod.
Yeah.
As I said, I really advocate for crowdsourcing for R&D because it's something we've done so far. Building the thing, it's going to be a test for us, so we'll see. That's the thing I'm afraid of. That's why I asked you twice if there are more people to join us, because I want to make sure, I want to have enough backup. If one of our facilities shuts down or whatever happens, I want to make sure we have a lot of people to work with it. So yeah, the problem that I'm having is really, will we build that thing correctly?
Well, we definitely want to invite you out. We help my investor group and others, we're Cisco hardware guys, and one of my guys innocent. We help with the Burning Man in state, location, and also down here, our guild fellows and others guys, we have a couple of the hardware places, along with this being a good resource to offer to you and plug into it. You can just have days when people get together. Like we do our process.
Yeah, let's get in touch. Let's get in touch. And the project like the DARPA project page, the X Prize, stuff like that, that's the kind of stuff I really like. The whole competition aspect is great for crowdsourcing. Roberto.
How did you get into this first, and how much workload did you have to do for
You're afraid I'm not working enough for NASA?
Yeah.
I have way too many slides. So, I was, if I tell you that you know my Reddit username, I'm not sure I want to do that.
We already know.
So I was one of the 19 first people on the thing. So I just happened to be on Reddit at that point. It was one of the, sometimes you can get something out from browsing Reddit. It was one of the first posts, and I saw that, and I saw the thing, and there was the project, the lead engineer position, and I say, yeah, nobody applied for it. I say, hey, let me give it a try. So that's how I got involved in it. To your second question about involvement, I don't sleep much. I have, like, my NASA job's taking me a lot of time. The early career NASA is taking me some more time too. And as soon as I get back home, I spend my time on Slack until like midnight or something, and my weekends are dedicated to it. I need to take a bit of a break though because it's very hardcore. But it's so far it's so full. What's the word? Fulfilling. It's just so rewarding that it's kind of a drag. I can't stop working on it. I will probably shut down this weekend. Yeah.
So I'm curious about your org structure on Slack. So you mentioned that the individuals who you designate to be the leaders on individual Slack channels or the specializations tend to be the most active. And how do you balance the selection of those leaders in that respect versus decision makers who would be like really hardcore specialists in a certain field who can make the decision as to what feedback to move forward on and what critiques to not entertain at this point?
It's a good question. So that's one of the curious things that you just witnessed happen on this kind of project. The people that know their stuff, they even without saying, hey, I know about my stuff, hear me out, they just stand out. So the leader will be listening, and the leader will usually know, okay, this guy is very knowledgeable about that thing. And because the way we work is really to take in account a lot of inputs, and because the leader is not always the most experienced one, not the one in power say, no, I know my stuff, my idea is right, he will have more tendency to listen to that guy and hear him out. So it works so far. We haven't had any crisis of people. We had some little stuff, people not agreeing, because it's normal, that kind of problems, you have disagreement. But yeah, the expert just stands out. They just stands out the way they work, just the professionalism, or just the quality of the work they come, and people, they just earn the respect directly without barely doing anything.
So are you saying that the leaders for, so let's say Arrow team, for example, are you saying that the Arrow lead, his responsibility would be to listen to the feedback, listen to the specialists and the experts in the field, and also be able to make be the ones to make the decision in terms of what next steps to take, but a colleague that he has is listening to
Right. Arlo is actually a bad example because the leader here is really knows his stuff. He's a great guy. Scott, if you're here, he's doing really good stuff. But in general, yes, the decision is really taken in usual at that level. So the green and blue level, people really take the decision by discussing all around them. It's like popular vote. Okay, do we all agree on this? That kind of stuff. The executive decisions, when needs to be taken, are usually more from Brent and myself. When there is something wrong going on, I say, okay, I usually try to not micromanage too much, but if there is something wrong, I try to give the guidelines at the high level. But if I see something, okay, this is problematic, then I step in, I say, okay, let's take a decision now. What do we know? What we don't know? Let's try to find something. But I try to not take too much executive decision either, otherwise I steer too much the thing away from what the people wants to do. I don't know, also I don't know I'm not an expert in any field. I'm an expert, I know a bunch of fields, but it doesn't make me the right person to choose also. But you need someone to say, okay, go for it. I think I haven't taken any question here.
I'm coming more to the corporate side, so I'm really interested. It's a competition yet. You want to win. So there are 30 teams left. How do you tackle the issue that sometimes perhaps a player from yours changes teams and takes the ideas with him?
Do you work for HTT?
No.
You don't?
No.
Okay.
Fine, I don't do much.
Question I'm asking that is because we had... Cut that.
We'll cut the stream.
So it happens sometimes. We have people changing team. So what can you do? An example we had was at the competition at Design Weekend. We had a couple of people coming to us. Hey, I know about you guys. We had one guy coming to us and saying, I was actually on Slack. I wasn't, participating, but I was stealing some of my ideas to my team, And what I want to say about that, going back to the ball, it's not the idea or the individual, it's the whole community. Something I believe a bit into. It's really the whole thing. Some people took our idea, and I know that guy wasn't selected. It happens. We want to win the competition, and I'm actually a very hardcore competitive guy, but I need to take a step back, otherwise it just will kill me, and I'm okay with losing also. Or, we don't even know what we're winning anyway. But it's just, you need to remember that it's a hobby. It's a cool engineering problem. I just enjoy working on that thing. That's what I'm trying to take. But yes, people are getting stolen I see from the corporate point of view, really issue there, stealing the people. Always having a backup helped me. I had some people stolen that were very great. I had a guy that did a huge job, and it wasn't. After a moment, it wasn't there. I was kind of guessing something. Sent him an email. He hinted me, I can do that much, but if I get paid for the same, it's even better. And I said, yeah, well, good for the guy. At least he found a job out of it. For you, it's a bit different because you're both getting paid, right? So have a backup, not rely too much on one person. I'm not an expert I'm really known for that kind of stuff, but for your point of view, that's all I can give what we had. The Borg. Be like the Borg. But don't change it. Yes, sir.
Apparently you had some free software, but then I saw ANSYS up there, which I think is not free software.
We had oh yeah. ANSYS is sponsoring us. So you saw it in the thank you, the thank you slide at the end. ANSYS is sponsoring us. I think they were sponsoring every team, and now they sponsor us some license. So we have some sponsors now, some corporate sponsors. Yeah, so that's very useful.
What's your budget for something like this, and what you need to go ahead?
Sorry, say that again?
Budget.
And what do you need to go ahead?
Oh,
What's your sponsorship budget? What do you need to go ahead within you?
that's a question more for Brent, which is a technical grant. We have the pod price is around 60K to be built. We have some downsized version of the pod in mind in case we don't get all the funding. We have some corporate sponsors to be coming in, so that looks good. We see what we reach. I'm not a great guy for budget, unfortunately, so I'm not sure I can answer the question correctly. So
what do you know is your next step you need to accomplish? You obviously need hardware help. You need locations.
secure the locations. Secure the locations. Have a good size manufacturing team. Fund to an acceptable level or campaign, and start ordering parts to all the 4 next steps. Yes, sir.
Have you considered any hybrid funding at all for your objectives?
Hybrid funding? I'm not familiar with the term, sorry.
Okay, well, it's more of a kind of like an aggregator as far as doing your project.
An aggregator?
Like when you're doing the milestones on your designing and stuff like that, have you considered any hybrid funding on that?
I'm not sure what.
Sponsors, that's just on the marketing aspect of it, what about the manufacturing aspect?
Okay.
Hybrid funding for that.
Yeah, I'll look into it. No, even thought about it. I'll look into it. I'll go.
So you guys were on Reddit, you guys went out and funded your own thing. When you guys go back to Reddit, how do you plan to utilize that for this going forward?
So I cannot say we'll be utilizing Reddit for that because I sent 2 emails to Reddit. They never replied to us. We really just wanted to kind of clarify a bit. Okay, a lot of people are using Reddit in all names, and we are not rLoop but Arlo. But some people, like in the press, can see like the Redditors building the pod. We want to make sure there is no issue with that. We'd love to be able to discuss a bit with them to see if they are interested in helping us out or doing something, or just telling us straight, oh, we don't care about it, do your stuff on your own. But yeah, so far no words on Reddit, so it's there is no return on investment from the Reddit community per se, except showing that people from Reddit one day put their stuff together and managed to do something over the internet.
I don't know, but like, have you considered China on your site right there? So is that Dongguan, then Dongguan area, or is that more or less in the actual factory side?
No, we don't have any manufacturing facility outside the US.
I mean, considering the resource of your economics as far as on funding the project, France usually runs all the 20 factories in Dongguan plus the other part of China. So you're talking about manufacturing. Wouldn't that be a key consideration on your part as far as on affiliation for your funding?
It could be. The philosophy I've adopted was more, I like something close to me so I can keep an eye on. But it will make sense also to look in those areas that are known for manufacturing and all the funding of those kind of things. We are really amateurs still on this, so we should try to learn. So we'll look into it. I think we are not sure exactly how to approach that kind of problems.
I got to connect with our guy who's retired. He used to run Bart's R&D lab. They're fixing, you notice they have the trains down, the buses, they go to these middle area. So what they figured out was a way structurally to build them so they don't cost $3 million a mile or $1 million. For something like this, if you could get it done, since it's $5 billion, not $50 billion, you could actually do a private toll roll subscription approach. But the people who fund it get a revenue share. And then the technology, you license out the technology,
Yeah.
how you build it, that somebody else big and manufacturer, just like Eli Lilly does with InnoCintive, they'll pay for you guys to do the sweat equity to build a proof of concept, and they'll license it so they can build this around the world
Yeah.
to the big companies, because you're taking the risk out of coming with a prototype. There's a way to do it. We should talk offline. Actually,
Yeah.
So.
Okay.
Also, in the central repository bank, usually like the Task and some of the other software, I think like Pete mentioning, just right here, that basically they get their licensing funded and sponsored on that, and that's how they license it. It's a central repository and
Thomas,
they
tell-
catalog the entire universe
Or
of the country.
tell them to take it offline while asking other.
Yeah, their aspect. You said everything first from the point of origin, so knowing mathematics, you would be pretty much 0, x1, that's basically finding out the central repository.
Okay. Well, I'll give you my card and I'd be interested in shooting me those thoughts. I have them written down.
Excellent.
Thank you for that.
So I'm going to ask a really dumb question. So
Go for it.
The picture that you had of the pod had a single dummy inside of it. So is that what's but the original artwork that I've seen from SpaceX seems to have 6 people. What's the projected size of it?
So we have some scaling up. We have a scaling up document we worked on, but it's a bit far behind me. Here we're really focusing on the technology demonstration. The actual size of the final system is still up in the air. It depends on what people think will be the right place. We haven't worked on that yet, or at all, because of the competition. So we're really focusing on just on the technological demonstrator, having the piece together. But that's the kind of stuff we'd like to look at in the future also. So I cannot answer that question right now.
The tube construction, if it were made out of aluminum, this train would be like 1,000 times easier and simpler. Instead now it's like you've got to do a maglev separate, where if I just had an aluminum tube, I can levitate off static magnets, and you could not crash a high-speed even if you tried. And I can do the propulsion off of it, and there's all kinds of other interesting bits that can be done with it, and it's super easy to produce.
There are lots of proposed tube design. One of those was like that. There is a lot of different approaches. Here we are constrained by the tube. SpaceX is giving us the tube, so again trying to focus on the thing of the competition. That's the way we're going. Can we improve or change the tube? Absolutely. I think there will be.
Now the other thing is, if you've got a steel tube, you can levitate with regular magnets and passive too.
Yeah.
Again, you can get away with having to have that stuff on the bottom. You can just levitate off the top.
Yeah, there are other ways to do that.
One question, I have no
Cut in time.
Here, but basically I work in the government metallurgy lab. So basically, as far as on the bits of type of material, have you considered, is it like 3 nines, 4 nines purity as far as on the actual material? Have you went to the London Metals Exchange? Are you a member of London Metals Exchange when it comes to mining for material as far as having a contract with NASA? Have you thought of that approach possibly?
That's a question for my structure guy, because he's the one that looked into all that. But yeah, I can answer that.
Yeah, he's right.
We gotta-
Yeah.
The two would be structurally magnified through an R, but it would depend upon the square root of where that location was as far as parametrics goes on the construction and building of that application.
Yeah, I see. Well, that would be interesting.
Let's see the question here.
I'm curious that they're asking questions about things that you say you have pondered. Is your document, do you have documentation that supports the reasons for why you made choices online that people could look at?
Yeah.
I mean, so in other words, I can see, just as your other question, bringing the people up to speed, they come up with cool ideas, and you may very well have hashed those around and came up with a reason for going to the A or B. They can get answers to those questions mostly by reading what we've written already.
Okay. Yeah, people can.
Yes, and next question.
People no, they haven't read that already, as far as I know. But people can read it and see. We justify the reason we've been doing a lot of those things in the document.
But also the reasons why you're not doing other things.
We went over some of it, probably not all of it. Reason behind that is really the time constraint. And we went with what we know works. We took the approach of systems that were proven. For example, the pressure vessel, we just followed the regulation CFR 44, I think, which is used for business class jets. So we just went with guidelines that are used for the stuff. Is there other ways to do this? Absolutely. Absolutely. A lot of people might argue, I would have done that that way. And I say, okay, yeah, you're probably right. But this is what we're going with right now, and we cannot go back and change it now. We say, this is what we're going with, making the best out of it, we see what it goes in competition. If there is a problem, then we go back to the drawing table at some point. But in the timeline and the milestone we have to meet, that's what we're going with right now. Running out of time?
Yeah, looks like we got a signal back there.
Right.
So I was wondering, considering the tools that you use so far, and that you maybe use and said that's not working out, are there any weaknesses or things that no tool out there right now that in-person collaboration
So you're asking me, because we are over the internet, what am I lacking versus in-person communication? Oh man, that's
It's just a fun number you have to go out. So 1, 3, 5, 7, 12, 18, 25.
probably.
Yeah. Ninjax are back. You're talking about Ninjax.
We're giving you some time to think about it.
Yeah.
There's some synergy just being in the lab with people.
That's the thing. I think but it's, when we have those like final moments when we're like making the final design report, for example, the final moment, the last 2 hours, we kind of needed what you just said, the synergy with the people. So we were like on Google Hangout, just chatting at the same time we're working. That's the kind of thing that's missing, like the human contact.
Yeah.
The rest, I think one big thing is I'm a very, I always need a whiteboard. And it sometimes can be hard over the internet to write on a piece of paper and show this is what I mean, That's something I miss. You tell me there are a lot of tools you can do that online, so it just, I don't know, I'm just missing my whiteboard.
That's the biggest problem. So here's my question. What do you think is your chance of getting this done right now as you are? What do you need, like, specifically? Like, what do you think the budget's going to cost you to get all this done? At the end of the day, get it ready.
100K. Plus something like 100K around there. Something like that would be helpful.
Yeah, because you triple redundant, maybe 300, because you have to assume, like the Cisco rule is, we need to be triple redundant what we think it is, because we're going to screw up. And if we have to hand off to anybody else, we have to be triple redundant what they think of, and then put another X for fuck-ups that we didn't even think about. So it's usually 3 times what you think it is.
So 180.
Cool, that's pretty good.
All right. If you have more questions, I think we are running out of time. It's 8 p.m.
Yeah, I want to, people may want to come up and ask individual questions.
Yeah.
The different Arlo team members, who are you here? Just the 3 of you?
Yep.
Yeah.
Okay.
We have other Arlo members. Raise your hands. So one there, one there, one there.
Those of you who still want to ask questions, I guess you can come up and be an individual Arlo.
Come to us. Grab a beer, grab a bottle of water.
Some of us are going to go off and attend another meeting, having to do with rockets and the like. So anyway, we want to thank you all for coming.
All right, thank you. Yes, it was the stream. Say hi, everybody. Hey, Rich. Say hi, Rich. I'll give you the link now.
Get your contract.
All right, yeah, we'll catch you guys later. Hey, team, we're here.
So we negotiated, like, you helped the US government get a better on the thing for Google to put the space. My governor-in-law.
Nice. Let me just sign out here. Okay. All right, guys, take it easy.
We're building a flying car too.
See, a lot of cool stuff going on. All right, catch you guys in the next event.